Okay children, let us see the next question. If the roots of the quadratic equation, so what is the quadratic equation here? That is x square minus 4x minus log a base 3 is equal to 0. So this is the given quadratic equation. Clear? So here roots are real. Roots are real. So here we can take that delta is greater than equal to 0. Delta is greater than or equal to 0. Okay. So why? Because here they given that nature of the roots. Then the least value of a. So this a value they are asking. A value they are asking. So first find that delta value here. So delta is greater than equal to 0. So which is equals to b square minus 4ac is greater than equal to 0 condition we have to check. Okay. So from this here b square is equal to minus 4 whole square. Okay. Minus 4 into here a is equal to nothing is there, so that is 1, and c is equal to minus log a to the base 3 which is greater than equal to 0. Clear? Yes. So from this one here minus 4 whole square which is equals to 16. Okay. And minus into minus, that is plus 4 log a base 3 which is greater than or equals to 0. Clear? So from this one here just 16 is there, that is a plus 16 is there, no? So that's why take here minus 16 on both sides. So 16 minus 16 plus 4 log a to the base 3 is greater than equal to 0 minus 16. 0 minus 16. Okay, why? Because we are adding minus 16 on both sides. Okay, so that's why 16 and minus 16 gets cancelled. So from this one here 4 log of a to the base 3 which is greater than equals to minus 16. 0 minus 16 means again we will get it as minus 16 only, no? So that's why. Now here divide this one, divide both sides of the inequation by 4. Why? Because here we are getting that 4, no? So that's why divide this one by 4. So 4 by 4 log a base 3 greater than equals to minus 16 by 4. So 4 and 4 gets cancelled, and here 4 cancels 4 times. Okay, 16 by 4 times. So the leftover here log a base 3 greater than equals to minus 4. Minus 4. So here greater than equals to is there, no? So this is in the form of logarithmic form. So convert this one into that exponential form. Okay, so to convert into that exponential form, so here we can consider this as log a to the base 3 which is equals to minus 4. This is a logarithmic form, log form. Okay, now convert into that exponential form, then here at the place of a we will get that minus 4. So 3 power minus 4 is equal to a. So children, already you know these conditions we learned in that logarithms, right? So which this is in the form of exponential form. This is exponential form. Okay, so from this one a is equal to 1 by 3 power 4. So which is equals to 1 by 3 power 4 value is 81. So what is the least value of a here? Which one is existing here? That is 1 by 81. Okay, so that option is there or not? See here. Yes, option 2. That is 1 by 81. So which option is correct, ma, here? That is option 2. Am I clear? Yes. So see that next question. So children, see that next one. If p into q minus r into x square plus q into r minus p into x plus r into p minus q is equal to 0 has equal roots. What they are saying? Equal roots. So the first condition they given that given quadratic equation p into q minus r x square plus q into r minus p into x plus r into p minus q. Okay, so which is equal to 0. This is the given quadratic equation. Okay, and they given that one condition, that is alpha is equal to beta condition also given. those two roots are given. Okay, so these two conditions they given in that question, and we need to find that 2 by q value we need to find out. Okay, so let us check that. So children, this type of questions they given means already we explained one of the question, that is 11th one I think so. So that is related to if a plus b plus c is equal to 0, then the roots of the quadratic equation are, okay, what are those two roots ma? 1 and c by a. So already we discussed in the previous questions. So the same condition here we have to apply. Okay, so why madam we have to apply means first we have to check that here it is satisfying or not. Okay, here a plus b plus c is equal to 0, it is satisfying or not. Whether it is satisfying or not, first we have to check that. If it satisfies, then only we have to go for that condition. Okay, so first check that if a plus b plus c is equal to 0 or not. A plus b plus c value we need to find out. Okay, so first find that here a plus b plus c value. So a is equal to here p into q minus r. Okay, plus b is equal to here q into r minus p. Okay, and here c, that is r into p minus q. So this value we need to find out. So which is equals to here p into q, pq, minus p into r, pr, plus q into r, which is qr, minus q into p, pq, plus p into r, pr, minus q into r, qr. Okay, so see here, so plus pq minus pq gets cancelled, and here minus pr plus pr gets cancelled, and here qr and here minus qr gets cancelled. Finally here the value is 0. The value is 0. So while you are checking that a plus b plus c, here we are getting 0. So a plus b plus c value we are getting here 0. So if a plus b plus c is equal to 0, then the quadratic equation ax square plus bx plus c is equal to 0 has the roots are 1 and c by a. So this condition we can apply. Why? Because here we check that a plus b plus c value we are getting here 0. So this condition satisfies no here. So that's why apply this condition. So by observing this condition here we can say that one of the root. What is that one of the root? That is 1. Okay. So from this condition here one of the root alpha is equal to 1 and another root beta is equal to c by a. Beta is equal to c by a. Another root c by a only, no? So from this given quadratic equation, what is the value of c here? C is equal to r into p minus q. So r into p minus q by a is equal to here p into q minus r. P into q minus r. So here we got that two values. One is alpha is equal to 1, another one is beta is equal to c by a value here. Okay, so from this condition and also given that alpha is equal to beta, that condition they given in that question. Okay, roots are equal, so that's why apply that condition here. So alpha is equal to beta. So from this condition here r into p minus q by p into q minus r, which is equals to here alpha is equal to value is 1. So from this one here p into r is pr minus q into r is qr, which is equals to p into q is pq minus p into r is pr. Clear ma? So from this one here pr is there, so transpose the terms pr, so minus pr become as plus pr, which is equals to pq plus qr. From this one pr plus pr, which is equals to 2pr, which is equals to, from these two terms take that q as common, so from this p plus r. Okay, so from this pr is equal to here q into p plus r by 2, p plus r by 2. Okay, so from this one PR by, just transpose the terms, P plus R is equal to Q by 2. R is equal to Q by 2. But what they asked in that question? 2 by Q value they are asking. But we are getting here a Q by 2 value. Okay. So from this one, 1 by PR by P plus R, which is equals to 1 by Q by 2. Then only we will get no. Okay. So from this condition, here P plus R by PR, P plus R by PR, P plus R by PR, which is equals to 2 by Q. This value only they asked now in that question, 2 by Q. So 2 by Q is equals to here what we got, that is P plus R by PR. So that option is there or not, see? So here the option is P plus R by PR. So which option is correct ma here? That is option 3. Okay. So let us see that next question. So children, see that next question ma. Here, if A into B minus C x square, A into B minus C x square plus B into C minus A into x plus C into A minus B is a perfect square. Here they are saying that this is a perfect square, then A, B, C are in. So here they said that is in perfect square. So perfect square means delta is equal to 0. If delta is equal to 0, then it is a perfect square, we can say that, right? So we can take that delta is equal to 0 condition. So delta is equal to here B square minus 4AC. B square minus 4AC is equal to 0. So from this one, here B square is equal to B into C minus A whole square minus 4 into here A is equal to A into B minus C, and here C is equal to C into A minus B, which is equal to 0. Clear? So from this one, here B square into C minus A whole square minus 4 into, here we can simplify this. So A into C is equal to AC into B minus C into A minus B, which is equal to 0. Okay. So from this one, here B square into C minus A whole square minus 4 into, here AC into, first simplify this, AC into, here B into A is equal to AB, and here minus B square minus AC minus into minus plus BC. First simplify inside that, so which is equals to 0. Okay, inside terms first simplify that, so which is equals to B square into C minus A whole square, B square into C minus A whole square minus 4 into, here AC into AB. So AC into AB, which is equals to A square BC minus 4A square BC or A square BC. Okay, next term, and here minus B square into AC, so which is equals to AB square C. Okay, minus AB square C. Okay, minus AB square C. Next AC into AC, so that is minus A square C square minus A square C square. Next one, AC into BC, which is equals to ABC square plus ABC square, ABC square, which is equal to 0. Clear? So from this one, B square into C minus A whole square minus, here just multiply with 4, so minus 4A square BC minus into minus plus 4AB square C. Next minus into minus plus 4A square C square. Next minus into plus is minus 4ABC square, which is equal to 0. Which is equal to 0. So from this one here, B square into C minus A whole square. Okay, just I will write that like terms together here. So after that I want to write this term. Why? Because here B square term is there, here also B square term is there, no? So that's why just write together here 4ab square c. Clear? Next, the leftover terms right here. Minus 4a square bc plus 4a square c square minus 4ab c square, which is equal to 0. Understand? So from this one, here these two terms we can take that, from these two terms we can take that b square as common. Okay, and here c minus a whole square, we can write that c square plus a square minus 2ac. Okay, plus 4ac. Already we taken that b square as common, no? So b square we taken as common, so that's why the leftover 4ac. Clear? Next, from these three terms, here how we can write that? Here a square c square is there. Okay, so from these three terms, here just write together. Here from these two terms we can take that minus 4abc as common. Yes or no? Here ABC term is there, here also ABC term is there. So take that minus 4ABC as common. So the leftover here A is there. Next, from here minus already we taken as common. So plus ABC we taken. So leftover A plus C. Okay. Plus the leftover term 4A square C square, which is equal to 0. Clear to you? Next. So from this one, b square into, here this is c square plus a square minus 2ac plus 4ac, which is equals to plus 2ac. Clear? Minus 2ac plus 4ac. 4 minus 2 is plus 2ac. Okay, and from this one, here minus 4abc into a plus c plus 4a square c square is equal to 0. Clear to you? So from this one here, b square into, here this one we can write it as c plus a whole square formula, yes or no? Or a plus c whole square, your wish, that is a square plus c square plus 2ab, which means 2ac. Okay, a plus b whole square formula only, no? So that's why we can write this one as c plus a whole square. Okay, minus 4abc into a plus c or c plus a, your wish, those two also same only, no? Plus 4a square c square, which is equal to 0. So children, just observe that from that first term and the second term, here c plus a, which means a plus c, and here also a plus c is in common. Okay, so you can write this one as a plus c also. Okay, so here a plus c is there, here also a plus c is there. So we can take that a plus c as common, no? So take that a plus c as common. From that one, a plus c, take it as common. Now the leftover terms here, b square and one more time a plus c is there. Here two times there, no, but we taken only one time as common. So still one more time is left here. So that's why b square into a plus c, b square into a plus c, and here the leftover minus 4abc, minus 4abc. Okay, minus 4abc plus 4a square c square, 4a square c square, which is equal to 0. Clear? So from this one, a plus c into, okay, now simplify this, b square a plus b square c minus 4abc plus 4a square c square is equal to 0. Okay, so from this term here we can take that. So children, see here, b square into a plus c whole square minus 4abc into a plus c plus 4a square c square is equal to 0. So here just observe that here also perfect square is there or not. See here, we can write this one as, again I am writing, see here, b square into a plus c whole square, b square into a plus c whole square minus 4abc into a plus c, okay, plus 4a square c square, 4a square c square, which is equals to 0. Clear? So from this one here, we can write this one as b into a plus c whole square. Shall we write like this? Okay, b into a plus c whole square. Again, b square, a plus c whole square, we will get that. Minus, just leave that middle term. The last term we will write here, say that. So plus we can write this one as 2ac whole square, which is equals to 0. So just observe that the first term and the last term. So this is in the form of, this is a square and the last term is b square. So a square plus b square plus 2ab term we have to write. So 2 into a is equal to here b into a plus c, a, and here b is equal to here 2ac. Okay, clear? So see that a square plus b square and here minus 2ab. Clear ma? So minus 2ab. Is it clear to you? Now this is in the form of a square minus 2ab plus b square. So a square minus 2ab plus b square, which is equals to a minus b whole square form is there. Okay, a minus b whole square. So write this one in the form of a minus b whole square. So a is equal to here b into a plus c. Okay, so a minus b is equal to here 2ac. So b minus a minus b whole square, which is equal to 0. Am I clear to you? So from this one, b into a plus c minus 2ac, just remove the brackets, which is equals to 0. Okay, so from this one, b into a plus c is equal to minus 2ac transforms into that RHS side. So we will get that one as plus 2ac. So from this one, b is equal to 2ac by a plus c. So the middle term, which is b is equal to 2ac by a plus c. So this is that related to a, b, c are in HP. A, b, c are in HP. So this is the relation of that HP, harmonic progression. If a, b, c are in HP, then if a, b, c are in HP, then the relation is b is equal to 2ac by a plus c. Okay, then b is equal to 2ac by a plus c. Okay, so here a, b, c are in what ma? Here a, b, c are in HP, harmonic progression. So which option is correct here? Yes, third option is correct, that is HP. Clear to you? Yes. So children, see that next question ma? Yes. So children, see here, just to see the reason up to now we discussed about this type of questions, no? So directly I will tell you this one, see here. So assertion is the roots of x minus a into x minus b plus x minus b into x minus c plus x minus c into x minus a is equal to 0. So after simplifying this, we will get that quadratic equation. Okay. So here they are saying that this quadratic equation roots are real. Roots are real, that is given in that assertion. So next in that reason, it is satisfying that condition or not, see that. So above quadratic equation, discriminant value is positive or equal to 0. So in that assertion they are saying that the roots of the equation are real. So roots are real. Okay, so children, we know that if the roots are real, then we have the two conditions. What is the first condition? If the delta is greater than 0, then the roots are real. Roots are real. And another condition is there. What is that? If delta is equal to 0, then also roots are real. Okay, but here there is a difference where it is here the roots are real but different roots, which means distinct roots. But come to that, delta is equal to 0. Here roots are real but roots are equal roots here. Okay, that condition only different. But here they are not asking about that equal and not equal roots. Just they are saying that roots are real. So real means these two conditions also applicable here. Okay, so in that assertion they are saying that the roots of the given quadratic equation are real. When it is real, if that discriminant value is greater than 0, which means discriminant value is positive. Positive means greater than 0. And another one is equal to 0. So discriminant values are greater than 0 and is equal to 0, then only the roots are real. Okay, that's what they are saying here. Understand? So assertion is correct as well as the reason also the correct explanation of that assertion. Okay, so if you simplify this one, then you will get that real roots. So you try that one. Understand? So which option is correct ma here? Yes, option 1, both A and R are true, and R is the correct explanation of A. Understand? So children, this is related to worksheet 3 problems. So after this one we will discuss about that concept 4. Okay, concept 4, that is related to applications of quadratic equations. So after that we are having another some other types of nature of roots. Okay, we will discuss in that concept 5. Okay, thank you all.